While standing on a bridge 30 meters above the water below, you throw a rock straight up into the air with a speed of 24 meters per second. What is the velocity of the rock when it hits the water? So we've drawn our picture up here on the board. There's you. You're throwing the ball upward with a velocity of 24 meters per second. It's going to get slower and slower and slower on its way up because the acceleration is always, for anything in midair, 9.8 meters per second squared down. We know the bridge is 30 meters above the water, and the final velocity when it hits the water is the question. Sometimes people mistakenly want to break this problem into two parts, on the way up and then on the way down. We don't have to do that. We can do this all in one part with our 5 variables because the acceleration the whole time on the way up and on the way back down is going to be negative 9.8. As long as the acceleration doesn't change, which it doesn't on the way up and on the way down, it's always the same, we can just use one equation and our 5 variables to solve. So now we have to pull some numbers out of our problem. First, what's the displacement of the thing that we're throwing? I know that it goes up and down, but that's the distance. The displacement is from where it starts on the bridge to where it ends up in the water, and that would be 30 meters lower. Because it's 30 meters lower, it's going to be negative 30 meters for the displacement. The initial velocity is upward, 24 meters per second, so it is a positive 24 meters per second. The final velocity is what we're trying to find. So that's my question mark. And I know that the acceleration is downward 9.8 meters per second squared, like it is for every problem where we throw something straight up into the air. We're going to use the equation that does not have time in it to solve for final velocity. So that would get me final velocity squared minus or equals initial velocity squared plus 2AD. The equation is almost already done for final velocity. I just have to get rid of the squared. So to do that, I would take the square root of my right side. I can now plug in some numbers. VF equals, V naught is 24 meters per second, and that's getting squared, plus 2 times negative 9.8 times negative 30 for displacement. And all that is under the square root symbol. When I plug that all into my calculator, what I'll get for final velocity out of my calculator is 34.12 meters per second. But we're actually not done. When you plug a square root into your calculator, you might remember this from your math class, they always told you the answer is either positive or negative, because the square root of 4 is 2 or negative 2. So in math class, you had to keep both numbers, either the positive 34.12 or the negative 34.12. But in physics, signs have meaning. Positive would mean that the rock has a velocity that's upward, and negative means that the rock has a velocity that's downward. Well, if we look at our problem, which way is this thing going? When it hits the water, it's coming down. So the only answer that makes sense is negative 34.12. The negative is because it's moving downward, which we know from the situation.